Hello, dear sir, madam. Thank you for time and opportunity given to me to present my paper entitled Design of Photovoltaic Wind Turbine Mobile Container for Disaster Area Using Homer, a case study, Cepu, Central Java. This presentation is present in the framework of the second Borobudur International Symposium 2020. The background of this study is in the area of Blora Regency and its surrounding, and the Cepu subdistrict in particular. When in the dry season many areas experience drought. Almost the Blora and surrounding area are in the red, orange, and yellow color zones as shown on the map. The community experienced difficulties with clean water for their daily needs, livestock, and irrigation. When experiencing a drought, there are still certain areas where water sources are available, but people have difficulty getting it. The source of water are deep wells, rivers, because the location is far from residential area and far from power source, so take it manually, and usually for the purpose of irrigation raise field, the farming community use a diesel engine using fossil fuels. From this problem and background, the study purposed to design a system in the PV module wind turbine mobile container for the first solution of the disaster area application in the Cepu city of Blora, Central Java. In the process of making a design using the help of Homer software, hybrid, renewable, and distribution generation system design, the steps taken in the software application operation are: the first, collect data related to solar radiation and wind speeds data obtained from NASA data. The second, identify and profile the electrical load. The third, planning a PV hybrid system wind turbines using the Homer software. The fourth, to simulate and optimize with variation of the four configuration and evaluate. This figure shows where all generators, PV and wind turbines are connected to the electrical interface in DC bus. Then enter the inverter system with a battery and connect to the main AC bus before being supplied to the load. Architecture is referred to as AC centralized architecture because the power generated by all generators is connected to the load through a single point. Since the output of hybrid system and battery is DC voltage, an inverter is needed to convert DC to AC voltage. The wind speed in the Cepu area is obtained from NASA. This figure shows the wind speed data per month in the Homer software. In the Homer software, wind speed data for all years need to be able to simulate a wind turbine. The average wind speed obtained from the study location varies between 4 7 meters per second per month, with the value of wind speed generated. In the study location, the can used to rotate wind turbines. The minimum wind speed value is 4.28 meters per second. And solar radiation data in the Cepu area obtained through NASA with the help of Homer will connect to NASA satellite via the internet by providing the location of the latitude and longitude of the reset location. Solar radiation data in the Homer simulation software require years of data to be able to make a photovoltaic from the NASA data on solar radiation per month. This is a load profile data consists of a water pump, there is a two-piece, reverse osmosis, lamp, charge socket, this power consumption, the period of time or hour of operation, and this total energy, then the estimate total usage load per day is 9,672 watt hour, and this is below is a profile of load. And this is figure A shows the electricity production, namely electricity production from PV of 2099 kilowatt hour per year and from wind turbine of 663 kilowatt hour per year, and the total electricity production generated is 3,566 kilowatt hour per year. And figure B show the electricity production produced is electricity from PV of 2,698 kilowatt hour per year and from wind turbine of 667 kilowatt hour per year, and the total electricity production is 3,365 kilowatt hour per year. And then figure C, so the electricity production produced in electricity from PV 2,682 kilowatt hour per year and from wind turbine 667 kilowatt hour per year, and total electricity production generated is 3,649 kilowatt hour per year. And then figure D show the electricity production generated from PV is 2,568 kilowatt hour per year and from wind turbine is 667 kilowatt hour per year, and the total electricity production generated is 3,235 kilowatt hour per year. And this is a hardware, so and this is slide is applied in the real world, and this is there is a wind turbine, photovoltaic, inverter, battery, water pump, reverse osmosis, socket charge, and this is applied and real and in the society application. The conclusion in the study, the design of PV wind turbine mobile container for disaster area using Homer can obtain the most optimal configuration result. The most optimal configuration in the first configuration after comparing the four tests. The first configuration has the second largest electricity production and first power consumption, the least excess electricity, unmet electricity load, and capacity shortage, and easy to assemble because it has dimensions smaller than others, even though it is the second lowest cost factor of the configuration with other. Okay, thank you for your attention. See you later.